Hello and welcome to Add-on. So today we have this question. Define the packing factor, and for a crystal with intercepts 3 Armstrong, 6 Armstrong and 2 Armstrongs along the 3 crystallographic axes having length 4 Armstrong, 8 Armstrong and 3 Armstrong respectively, and after that find the Miller indices of this plane. So let's start. Now what do you mean by packing factor or atomic packing factor? Well, the atomic packing factor is simply a measure of how tightly atoms are packed in a unit cell of a crystal. So let's imagine a box full of marbles. So if the marbles fill up a lot of space, the packing factor is very high. So the APF or the atomic packing fraction is the ratio of the volume occupied by the atoms in a unit cell to the total volume of the unit cell, right? So mathematically we can express this as the number of atoms per unit cell multiplied by the volume of each atom divided by the volume of the unit cell. Now we will move on to calculate the Miller indices for the given plane. So Miller indices are a way of labeling planes within a crystal. They tell us about the orientation of a specific plane in relation with the crystal axis. So let's check what is given. We are given that the crystal's intercepts along 3A, 6A and 2A are the intercepts along x-axis, y-axis and z-axis. So let's write it. The axial units along the 3 axes are A equals to 4 Armstrong, B equals to 8 Armstrong. Along the y-axis and along the z-axis we have C equals to 3 Armstrongs. Now the intercepts are given by, let's suppose P is the intercept along x-axis, so we have 3 Armstrong equals to P. Q equals to the intercept along y-axis, we have 6 Armstrong. And R is the intercept along z-axis, we have 2 Armstrong. Now, let the Miller indices be, let the Miller be H, K, L. Now we will calculate the Miller indices. So for that we will write PA is to QB is to CR as we are taking the ratio, which is equal to 3 is to 6 is to 2. Now we will calculate the Miller indices for each axis. So for x-axis we have P equals to the intercept along x, which is 3, divided by the axis length, which is 4. Similarly for y-axis we have Q equals to 6 by 8, which we can write as 3 by 4 by simplifying. Now similarly for z-axis we have R equals to 2 by 3. Now comes an important step. So to find the Miller indices, we take the reciprocals of this P, Q and R. Why do we do this? It's because Miller indices are defined in terms of the inverse of their intercepts. So let's find the reciprocal. So the reciprocals of the intercepts are 1 by P, which is equal to 4 by 3, 1 by Q, which is equals to 4 by 3, and 1 by R, which is equal to 3 by 2. So we have the reciprocals equal to the fractional triplets and the reciprocal equal to 4 by 3, 3 by 2. Now to get clear fraction, we will multiply each of them with the LCM. And the LCM of 3 and 2 is 6. So we will multiply each term with 6 to get the clear fraction. 4 by 3 multiplied by 6, 3 by 2 multiplied by 6. So we have 8, 8, 9. So this is the set of Miller indices for this particular question. Therefore, Miller indices for this particular question is 8, 8, 9. Thank you for watching.